Hello everyone, we are Team Honored Ones and we have built RepoPilot AI, a repository grounded engineering assistant. The problem statement asks us to build a system that understands the code deeply, answers the question with real citation, and never hallucinate. So let me show you how we do that. First of all, there's a GitHub link and we connect it to our AI system. As you can see, this entire repository has been indexed into 56 chunks. Now what does that mean? So first is this repository is first converted into a vector embedding, numeric vector embedding using Gemini, and then this vector embedding is then used or stored in ChromaDB. Now semantic search happens where similarity search across all the code chunks finding the most relevant places based on meaning, not just keyword. And the top matching chunks along with their file paths, line numbers and surrounding context get assembled into a prompt. Then Gemini generates a response, but it's constrained to only cite information from retrieval journals, no outside knowledge, and therefore it helps us to provide answers that is grounded in reality. Let me show you. Explain the architecture. So as you can see, it's the answer based from evidence from the code and suggestions what practically should next be implemented, along with all the sources mentioned from the repository, with a confidence score of high. Now this is a good interface, but let's move on to even better one. Here it is. Extension. So you may ask, what's the difference? Why VS Code extension? Well, the problem statement didn't really specify interface, but most teams might build a website. So we ask, why make developers switch context? Our extension lives right where you need to write your code, in the sidebar. Not no alt tabbing, no copy pasting between the windows. And this is how assistant should work, right? So let's explore a few of the more functions that we have implemented. So first would be safe refusal. Uh, like I would ask it, what are the GraphQL's? So as you can see, there is no mention of GraphQL in provided context. Because I ask a certain question, it doesn't mean it will hallucinate to answer this for the user and would safely fall back to refusing that it doesn't exist, citing all the sources present. The next thing would be asking uh, entry points. The main entry points in the code are not explicitly defined in the provided context. So it could not just answer simple questions where the answer is directly visible, but also because of its understanding of the code, it could help us to understand even beyond the surface, citing all the lines, path files as well, and the next practical step to implement. Now, the next step was PyTest generation. That is, it generates functions to understand if our code is working properly or not. So let's see. Test. And it generates set of functions to test if the functions or the code is working properly or not. Now let's run this test, and as you can see, now it's showing all the errors present in my code. So yeah, in all of this process, RAG, that is retrieval augmented generation, was used. How does that work? Well, your question gets embedded into a numeric value, then the semantic search works. The context is sent to LLM, and therefore a grounded answer is provided. So, in all of this, when the developer is trying to understand the repository, no hallucination happens whatsoever, and therefore the code base remains intact with the changes that you are making with the AI as well. So, thank you. That was our project.